Next up in grasping complexity is surprise and intrinsic volatility. The next important consequence of complexity is surprise. Surprise can also emanate from insufficient information or knowledge. However, complexity engenders contingency in the sense of absence of certainty in what may happen. So even though we said Chad may not get hit with a cyclone and Singapore may not get a blizzard, we don't know what can happen at Chad and Singapore, right? Many things can happen. Luhmann even states that by complexity we would like to understand that there are always more possibilities than can be actualized. So Mother Nature keeps giving you realizations or actualizations of the complex system at any location, but there is a smorgasbord of many more possibilities that we haven't realized or Mother Nature hasn't shown us, but she's holding all the cards. It means there can only be one event happening at a particular moment out of a myriad of possible events. Several interlocking, reinforcing and balancing feedback loops in complex systems regularly result in convoluted recurrences that amplify specific changes and suppress others, often with significant delays that further challenge human cognition. Add emergence and downward causation and you have the unpredictability in what will happen, even with a reasonably good understanding of how complex the system is in its workings. However, for the actual event to constitute a surprise, it must fall outside the normal range of violation for that system. For instance, just because you do not know whether what weather would be like before waking up in the morning, it would not be a surprise if it was either sunny or snowing in Sweden in December. So weather happens, climate is what you expect. You expect December to have a lot of snowy days, but weather is what you get, so you may wake up to a sunny day. On the other hand, if it snowed in Singapore, it would definitely constitute a total surprise, although the dynamic stability of complex systems operating far from equilibrium keeps them within normal variability most of the time. So Singapore is very unlikely to get snow, whereas Sweden may end up with more of snow during December than sunshine. Changes in their elements, interactions or environment can suddenly push them into unexpected states, as we'll see. Surprise. Furthermore, it also constitutes a surprise when such complex systems unexpectedly remain within their normal variability regardless of intense activity to change their current states. Even combinations of changes that are insignificant on their own can interact to produce surprise or even catastrophe. More on that in a moment. So here is 913, again a prop. Massive seagrass die-off in Florida constitutes a surprise in the sense that the system has the possibility of having such a die-off. Could be because of an anoxic event and some other nutrient runoff creating some interactions in the water column and so on and so forth, but it is a surprise, especially when it's very large scale. You may have very small scale things, but when it happens at such a large scale that it can even be seen in satellite pixels, then you know it's a surprise. Next, moving to intrinsic volatility, Perrow takes the consequences of complexity further. It's not just that combinations of insignificant changes can interact to produce surprise, as described in the previous section. They can also generate disaster. He suggests that complex systems are subject to destructive events inherent to the systems themselves and therefore unavoidable. This intrinsic volatility of complex systems is a consequence of complexity and makes some disasters simultaneously unpredictable and inevitable. It is essential to remember that most disasters are preventable. Okay, so disaster preparedness, knowing the risk and vulnerabilities and exposures, is all about preventing disasters, being prepared and mitigating the impacts, recovering fast and so on and so forth. So it is essential to remember that most disasters are preventable when complexity is just hampering understanding and effective risk reduction. However, rich, dynamic and non-linear interactions can, under certain conditions, cause disaster in itself. And there are disasters Perrow describes, with 3 Mile Island nuclear accident that we just looked at being his archetypical case. Okay, so here is Perrow's words. Here are Perrow's words. The accident had its cause in the interactive nature of the world for us that morning and in its tight coupling, not in the discrete failures which are to be expected and which are guarded against with the backup systems. So many disasters are expected and guardrails are put in. Most of the time we don't notice the inherent coupling in our world, because most of the time there are no failures, or the failures that occur do not interact. But all of a sudden, things that we did not realize could be linked, such as buses and generators, coffee and loaned key, became linked. The system is suddenly more tightly coupled than we had realized, even though all the couplings existed all the time. When we have interactive systems that are too tightly coupled, it's normal for them to have this kind of an accident, even though it is infrequent. It is normal not in the sense of being frequent or being expected. Indeed, neither is true, which is why we were so baffled by what went wrong. It is normal in the sense that it is an inherent property of the system to occasionally experience this interaction. So it may be some kind of an irreducible uncertainty, and nonetheless you have to keep on trying to understand the complex system and all the feedbacks and the links within the system to see if all possible disasters can be mapped, even though you have possibilities of not mapping all of them or not understanding all of them ahead of time. There are numerous other examples of such normal accidents in which small errors that are inevitable in complex systems combine and spread between parts that are dependent on each other in various ways, and they produce baffling effects. For example, the 2020 stock market crash was triggered by growing uncertainty concerning what the impact the COVID-19 pandemic would have, making the Dow Jones Industrial Average fall 36% from 20th February to 20th March in 2020, even before the real onset of the pandemic. It had nothing to do with the actual impact of the virus. The slump ended about a week after the global death toll started to escalate, with unprecedented recovery and continuous growth throughout the rest of the pandemic until the war in Ukraine began to loom. Seemingly random spikes in food prices in Africa and rapid transformations in dominant plant species in freshwater marshes of the Everglades are other examples. The trick, of course, with these natural systems of freshwater marshes and food prices in Africa and the stock market is that human behavior and human responses in anticipation to events play a big role. So food prices can spike just because, let's say, El Nino forecast was made. People think agriculture will be negatively affected, so they start hoarding grains, or they stop exporting grains, and so on and so forth. So it's not the disaster, but it's the expectation of a potential disaster that begins to in fact make things worse, because people are taking anticipatory actions to protect themselves in case there is an accident, making it worse for somebody else, right? If India doesn't export grains, Indonesian rice price goes up, for example. Okay, so here is the Dow Jones Industrial Average for 2019 to 2021, with the 2020 stock market crash that occurred here even before the COVID, just in anticipation of COVID arriving from China and other places into the US. So the stock market crash between 20th February and 23rd March is clearly seen here, and then it shot up way beyond what it was before the pandemic itself. Again, this is irrational exuberance, as Alan Greenspan would say. Okay, so should I keep continuing? Maybe I should read off a bit more. No matter how hard we try to grasp and address this kind of destructive event, we often make the wrong diagnosis and may even aggravate the problem by trying to solve it. So actually I have to run to another meeting, so let me actually stop it and we'll come back and read it. This is already almost 10 minutes long anyways, but I will continue this intrinsic volatility part in the next podcast. Okay.